Today we are going to see the next chapter, computer organization. So in this video we are going to discuss a brief introduction about the computer organization, like how the components are get connected or organized, basics of microprocessor, characteristics of microprocessor, and how the communication takes between CPU and memory. Finally, we are going to learn different types of microprocessors. First, in this introduction part of computer organization mainly deals with the hardware components of the computer system. It includes input or output devices, CPU, storage devices like primary memory, which is called main memory, secondary memory. It is mainly concerned with how the various hardware components operates and also deals with how these components are interconnected to implement a proper specification. The next one, what you see is two parts. One is computer organization and another one is computer architecture. Both defines similar, but computer architecture deals with the how to design the computer. In other words, computer organization deals with the hardware components that are transparent to the programmer. So these are the main difference between computer architecture and computer organization. Next one, we are going to learn basics of microprocessor. We all know that CPU is the major component of the computer which perform all the tasks. It is the actual brain of the computer system. That is why we call it as integrated circuit. Integration means two or more functions combined together to form a single circuit is called integrated circuit. The first microprocessor was introduced in 1970s, 4008, developed by Intel company. Microprocessor is a programmable multipurpose silicon chip. So it is mainly driven by clock pulses. So it has an inbuilt clock based on each and every second. Microprocessor works the various processes and it accepts input as a binary data. Microprocessor will process and provides the output according to the instructions stored in the memory. So here you can able to see the block diagram of the microprocessor. Here the input is given to the microprocessor. After that, from the memory it takes the instruction based on it process the input and produce the output. Microprocessor is mainly made up of three main units which we have discussed in the chapter 1 already. ALU, arithmetic logic unit, control unit and registers. Here register is also called memory. Next one is the microprocessor is able to communicate to the memory unit, that is ROM, read-only memory, RAM, random access memory, and also with the input-output devices with the help of the system bus. Here in this block diagram, it is mentioned as system. So this system bus is a collection of wires integrated together. There are three types of buses. They are address bus, data bus and control bus. So where the address bus carries the address of the memory location and the data bus which carries the data from the location to the another location, and the control bus which carries the control flow from one location to the another location or from one device to the another device. All these buses used to communicate is used as a communication channel which the microprocessor used to communicate from one devices to another devices. Next we are going to see about the characteristics of microprocessor. So a microprocessor performance mainly depends on three characteristics. First one is clock speed, second one is instruction set, and the last one is word size. Now let us see one by one. First one is clock speed. I already in the basics of a microprocessor, every microprocessor is driven by a clock pulses. So here every microprocessor has internal clock which regulate the speed of the microprocessor. So based on the speed, it executes the instruction one by one. So at the speed at which the microprocessor execute instruction one by one is called clock speed. And the clock speed is measured in megahertz and gigahertz. What we call it as megabyte or gigabyte. Second one is the instruction set. So the instruction is nothing but a command which is given to the computer to perform an operation on data, which we call it as an instruction. So the basic set of machine level instructions that a microprocessor is designed to execute is called as the instruction set. Here two or more instructions are combined which are programmed to the microprocessor for execution, that we call it as instruction set. Now the last characteristics of microprocessor is word size. So far here the number of bit that can be processed in a single instruction is called its word size. The term bit we have already discussed in number system in chapter 2. It means binary digit. The number of bit processed by the microprocessor in a single instruction we call it as word size. So this word size determines the amount of RAM, how much the amount of RAM will be accessed by the microprocessor at one time, and the total number of pins of the microprocessor. The word size depends on two things, that is the amount of RAM accessed by the microprocessor at one time. Second one is the total number of pins on the microprocessor. So this is all about the characteristics of microprocessor. Next topic what we are going to see is data communication between CPU and memory. The CPU has three types of registers for this communication purpose. First one, memory data register, shortly we call it as MDR, which is the data transfer between memory and the CPU. Second one is the memory address register, shortly we call it as MAR. So it holds the current address of the instructions, that is the instruction which is currently executing. The address of the instruction stored in the memory address register. Next one is the program counter, that we call it as PC, which is the special register in the CPU which always helps the address of the next instruction to be executed. Example, if an instruction is executed in CPU, the next instruction which is to be executed is stored in the PC, that is program counters. Next we are going to study about the bus. We call it as system bus. We already knew about the word bus in the previous block diagram. Once again, bus means the set of wires which is integrated together is called bus. There are three types of buses. One is address bus, data bus, and another one is control bus. First one is the address bus, which is mainly used to point the memory location. It always holds the address of the memory location. Here the additional component is used, that is decoder. A decoder is nothing but a digital circuit which is mainly used to point the specific memory location where the memory content is located. And the next one is the address bus. I already said the address bus which carries the address of the memory location. So here the address registers connected with the address bus which provides the address of the instructions. So the data by which carries the data between the memory and the CPU. The difference between address bus and data bus is the address bus is unidirectional, whereas the data bus is bidirectional. Bidirectional means it sends the data and also receives the data, whereas the address bus will send the data and it will not receive the data, that is unidirectional. Last one is the control bus, which controls the read and write operation, that it will read the data from the memory to CPU, also helps to write the content to the memory. All these operations are controlled by the control bus. Thank you, students.